So today we're tackling some machine learning concepts that, can really trip people up in practice for the CCDV-F exam.
Oh, yeah, they definitely do. It's easy to get caught out.
Right. We're tackling some seriously practical stuff today. Things like when you should even bother with ML versus traditional programming, how to prep your data for supervised learning, and what happens when your model starts drifting in production.
Yeah, the real world messy stuff.
Exactly. So let's jump right into some real problems so you can see how these topics get tested.
Sounds good to me.
Okay, so let's start with a classic trap in CI workflows. So say a Claude session generates some code for you,
Hmm.
and now you want another Claude agent to review it. What is the best way to improve that review quality? Because, my instinct, and I think like most developers' instinct, is just to keep that exact same session open.
Right, just tell it to review its own work.
Yeah, like challenge your previous assumptions,
Hmm.
or maybe feed it the test logs. It already has all the context, right?
Which sounds totally logical, but it's actually this massive trap called familiarity bias.
Oh, wait, really?
Yeah, if you use the same session, the model just inherits its own original assumptions. The underlying weights are already, like, primed with the exact logic it used to write the code in the first place.
Ah, okay. So it's like asking a student to grade their own homework.
Exactly.
Even if
Yeah.
they try to be critical, they're just anchored to their initial thought process.
Spot on. To get an objective analysis, you have to run a completely separate Claude review session
Okay.
using just the PR diff, so the specific code changes, and fresh context. That's what breaks the anchor.
Got it. So a targeted, fresh session gets us objective code review.
Yeah,
But before we even review code, we often have to actually find it in these massive code bases.
right. Oh, legacy code. Fun.
Yeah, exactly.
Yeah.
So let's say a Claude agent is investigating a legacy service error. What should its first move be to locate the implementation efficiently? Do we use bash commands for recursive searches, read the entire module tree into memory, use a glob command for source files, or use grep for specific strings?
What would you do?
Well, in a real-world scenario, I'd probably use glob to just get a list of all the file paths, just to understand the repo structure.
Okay.
Or, honestly, if it's an AI agent, why not just have it read the whole module tree to get full context?
Because that is a great way to waste your API costs and completely blow out your context window.
Right.
Yeah, reading the whole tree is like reading a textbook cover to cover when you only need like one single fact.
I think so.
And Glob just gives you file paths. That doesn't actually help you find where the bug lives.
So we use grep.
Right, you use grep because it searches the actual contents. It acts like the textbook's index. You locate the specific identifiers first, like the error strings or function names, and then you only read the specific files you actually need.
Okay, yeah. Targeted search saves tokens. So once the main agent finds that bug, it often delegates the actual fix to a subagent, which introduces a really dangerous blind spot, which is memory.
Yes. Orchestration is incredibly tricky.
Yeah.
Imagine you have a support coordinator agent and it's delegating a billing investigation to a subagent. What absolutely must be included in the subagent's prompt?
Well,
Because since subagents are spawned by the parent, a lot of people just assume you can rely on the parent's conversation history.
right. Don't they just share the same memory?
No, and that is the most common architectural mistake people make.
Wait, really? They don't?
They don't. Subagents do not magically inherit the previous shift's memories. Architecturally, when you spin up a subagent, you're making an entirely new API call with a blank context window.
Oh, wow.
Yeah, they do it on purpose to save tokens and keep the agent focused.
Okay, so if you assume they know what happened earlier, they're just flying completely blind.
Exactly.
And you definitely don't want them repeating all the lookups because that just burns through your API resource.
Right. It's literally like a new shift worker coming on duty. You have to explicitly pass them a handover briefing. So verified identity, order records, and their specific goal.
Okay, so explicit handover solves the memory gap. But when these agents go to actually execute tools, like, say, an expensive refund, we need strict safety.
Oh, definitely.
Let's say your support agent keeps calling a process refund tool before checking eligibility. Do we add examples to the prompt, parse the assistance text, strengthen the system prompt, or add a prerequisite gate?
What's your gut say?
I feel like prompt engineering is the go-to here, right? Just put "do not refund without verifying" in huge all caps in the system prompt.
Yeah, and that is a classic LLM trap.
Oh, is it?
Because prompts and text parsing are probabilistic, they aren't deterministic. A really strong system prompt is basically just a polite sticky note on a bank vault asking people nicely not to enter.
Oh, man. Let me guess. The prerequisite gate is the physical keycard swipe.
Spot on. A gate structurally prevents the tool from running at the code level unless the verified state is present. Programmatic checks will always beat prompts for critical safety.
A sticky note versus a keycard swipe. I love that. So prerequisite gates catch bad tool actions. But how do we catch bad generated code? Say a Claude agent generates data adapters that compile totally fine, but they keep failing on weird edge cases. My instinct is just to write a much longer, more detailed specification so the model can, reason through it before writing the
You
code.
see, writing a massive prompt specification is like giving a chef a 50-page recipe and just hoping for the best.
Right.
The AI needs functional feedback, so the correct answer is test-driven iteration. You create the tests first, and then you iterate using the failing results.
Okay, so test-driven iteration is like tasting the soup after every single ingredient is added.
Exactly.
It provides a measurable feedback loop that a long instruction manual just can't match. So test handled code failures beautifully.
Yeah.
But what happens when the tools themselves fail? Let's hit our last topic here. Model Context Protocol, or MCP, tool error handling.
Right, so imagine an MCP tool rejects a full text retrieval request because you hit a licensing limit. In traditional software, if an API fails, you almost always just set up a retry with backoff.
Right. Give it a second and try again.
But this isn't a network timeout, it's a hard licensing limit. Retrying with backoff here is like banging on a locked door forever. You need to read the close for licensing sign and move on. You have to return an is error flag is true, categorize it as a business rule, and tell it not to retry.
Because retrying just wastes compute. And returning an empty successful result is even worse, because it hides the real problem from the agent completely. That's all the key points we shared for the CCDV-XM today. Thanks for watching. If you found this helpful, subscribe and leave us a comment.